Take a look at this fraction. We have 3 divided by root 2. Is this a correct final answer? In most mathematical examinations, it is not. You are expected to remove the surd from the denominator, and the process involved in removing a surd from the denominator is what we call rationalization. Rationalization simply means the elimination or the removal of a surd from the denominator of a fraction. And by the end of this lesson, you will be able to rationalize 2 types of denominators. One is a 1-term denominator, called monomial. The second one is called the 2-term denominator. 2-term denominator called binomial. So basically, these are the 2 types of denominators we have. Now let's take a look at the first one, 1-term denominator or a monomial. So when we say a monomial or a 1-term denominator, it refers to a fraction which has only 1 term as the denominator. For example, in our example here, we have 3 divided by root of 2. The term as the denominator is only 1, the root 2, and so this is called a monomial. Now, let's take a look at another one. We can also have 3 divided by root of 2. Now, is this also a monomial? If you say yes, you are correct, because this is also a 1 term. For you to be able to differentiate whether a particular denominator is a 1 term or not, always look out for any addition or subtraction sign. If you can't see any addition or subtraction sign in the denominator, it is automatically a 1-term denominator. So this is a monomial, and that one too is also a monomial. Now, how do we now eliminate the surds under these 2 types of monomial fractions? Let's take a look at the first one. We have 3 divided by root of 2. Now, when you have a fraction like this, rationalization aims at rewriting this fraction in a different way without changing the actual value of the fraction. Now, we want to rewrite the entire fraction here in a different way without changing the actual value of this particular fraction. Now, let's ask ourselves, what number can we multiply by this fraction and then we'll get the same value? What number can we multiply by this fraction and the product will be the same as this? Guess? 1. That is correct. If we multiply the entire fraction here by 1, we will still have the same 3 divided by root of what? 2. Now, if we have something like this, root 2 divided by root of 2, what will be your answer? 1, right? Because any number divided by itself, the outcome is 1. So we can rewrite this 1 in this particular form, and then we'll now multiply it by our fraction. Remember, the goal is that after multiplying, our fraction should be the same. So if this divided by this will give us 1, if we multiply this by our fraction, the outcome that we will get will also be the same as this one, just that the structure may be different. Now let's do that. So here, in place of the 1, we can replace it this way. So in knowing that we can have 3 root 2 multiplied by root of 2 divided by root of 2. This is the same as 1, but we don't write the 1, we replace it with this. Now, we move ahead to simplify. So here, when you have two fractions and then you are multiplying, we multiply the numerators and equally multiply the denominators. So we have 3 times root 2 all divided by root 2 multiplied by root of 2. Now, we simplify. 3 times root 2 will give you 3 root of 2 all divided by root 2 times root 2. Another rule of surds is when you multiply a root of a number, multiply by itself, the root of itself, it will give you the same, which is equal to 2. So root 2 times root 2 will give us 2. Root 3 times root 3 will give us 3. Root 4 times root 4 will give us 4. Root 5 times root 5 will give us what? 5. Why? Because root 2 times root 2 is the same as root 2 square, right? And then when you have a square and a square with a square, you go away with the square, giving you 2. So the root of a number multiplied by the root of the same number is equal to that particular number. So here to root 2 multiplied by root 2 will give us 2. Therefore, the rationalization of this particular sum will be 3 root of 2 all divided by 2. 3 multiply root 2 all divided by 2. Now, when you take a look at our final answer, the root we didn't eliminate the root entirely from the fraction. We just changed the position. It was in the bottom, now it is now on top. Now, when you simplify, break this down, the value that you get will be the same as the value that you get. However, in this particular case, we no longer have our surd as our denominator. So we have successfully rationalized, or we have successfully eliminated the surd from the denominator. Having the surd as the denominator has no any issue. Anytime you have a surd as a denominator, you will have to rationalize that. Now, from this, anytime you are to rationalize a fraction which has a monomial denominator, a 110 denominator, all you need to do is take the denominator, multiply it by itself, take the same denominator and you multiply by the denominator of that particular fraction, and then you go ahead to simplify. Welcome. In the first part of the video, we look at how to rationalize monomial denominators. Now we are going to look at how to rationalize binomial denominators. I mentioned that one thing that you can use to identify a binomial denominator is to look out for either a positive or a negative sign in the denominator. So when you look at our fraction here, we have 4 divided by 2 plus root of 2. This plus separating the 2 and that of the root 2, making it what? 2 different terms. And so it is a binomial denominator. If there wasn't any plus here and the 2 was attached to it, it would have been a monomial. So keep it at the back of your mind that anytime you see the operation plus or minus in the denominator, it is equally a what? A binomial denominator. Now, in order to rationalize a binomial denominator, we will need to look for the conjugate of the denominator. The conjugate of the denominator. A conjugate of a denominator. And the conjugate of a denominator refers to an expression which is formed by changing the sign in an expression whilst maintaining the terms as they are. Now, this is an expression, so the conjugate of this particular expression will be formed by just changing only the sign in between the terms whilst maintaining each of the terms the same. And so when we have 2 plus root of 2, the conjugate of this particular expression will be 2 minus root 2. Remember, the only thing you need to do is to change the sign. So if the sign is positive, you change it to negative. If the sign is negative, you change it to positive. Example, if you have 3 plus root of 5, 3 minus root of 5, the conjugate here will be what? 3 plus root of 5. So a conjugate is found by changing the expression between the two terms, whilst maintaining the terms the same. Now, this is our conjugate. Now, after finding the conjugate, we now take the conjugate and multiply it by the denominator, multiply same by the numerator. And so in doing so, we have 4 divided by 2 root 2 multiplied by our conjugate is 2 minus root 2, 2 minus root of 2. We take our conjugate, we multiply by the numerator, the same conjugate multiplied by our denominator. Now, when you have it this way, let's also have it in the mind that the entire fraction here is equally equivalent to 1. Any number divided by itself is 1. So we have 2 minus 2 root 2 divided by 2 minus 2 root 2. It will give us 1. Meaning, when we simplify our expression, in the end, even though the arrangement may be different, but the actual value will be the same. Our goal is to eliminate the surd from the denominator. And so, let's go ahead to simplify. Now, when we have this, when you have two fractions, we multiply the numerators, multiply the denominators. And so we have 4 into brackets 2 minus root of 2, all divided by 2 plus root 2, also multiplied by 2 minus root of 2. This also times this. Now let's look at the expression in the denominator. Does it look familiar? Yes. Difference of two squares. Difference of two squares says that if you have a plus b multiplied by a minus b, it will be equals to a square minus b square. Now let's take a look at whether it really looks like our expression. They say a, when you have a 10 plus another 10, you also have a 10 plus another 10 in bracket multiply by the same term minus the same term, here to the same term minus the same term. So it's also difference of two squares, that it will be equals to just this one squared minus the second term squared. And so we can apply difference of two squares here to simplify our denominator. And in doing that, we'll have 4 divided by 4 into bracket 2 minus root 2, all divided by, we say this one is difference of two squares. So just take one term square minus the second term square. So the first term is 2 square minus the second term is root 2 square. Difference of two squares. Difference of two squares. Now we can now go ahead to simplify. So in simplifying, we will have 4 times 2 will give you 8. 4 times root 2 will give you minus 4 root of 2, all divided by 2 square will give us 4 minus root 2 square. The square here will cancel with the square root here, so we'll have 2, which will be equals to 8 minus 4 root 2, all divided by 2. Let's take note. Don't be tempted to subtract this from this. Remember, in addition and subtraction of sets. If they don't have the same rules, you can't add them. So here the 8 is not a surd, so we can't subtract the 4 from the 8 here. And so the simplification will be 8 minus 4 root of 2 all divided by 2. And that is exactly what rationalizing, or how we rationalize binomial denominators. Now, let's go over it again. So, binomial denominator, a denominator with two terms. Usually, they are separated by either positive or negative sign. So, when you take a look at our denominator here, it is being separated by positive or a positive sign. So, there are two. 1, 2. We can have trinomials, but in SARS, we only deal with binomials. Now, when you have a binomial, the first thing you need to do is to look for the conjugate of the denominator, which is this. And in finding the conjugate of the denominator, we may mention that you only change the sign in between the terms, whilst keeping the terms the same. So here is the denominator, the term 1 and then the term 2. So we just maintain them but change the sign in between the terms, which will give us 2. Here the sign is positive, so the opposite will be negative root of 2. That will give us the conjugate of this. After finding our conjugate, now we now take our conjugate, multiply by the denominator of our fraction, which is 4. Take the conjugate, multiply by the denominator, which is 2 plus root 2. Then we move ahead to simplify. When you have two fractions multiplying, and 4 times is 4 times 2 minus root 2, all divided by this times this. So we put them into brackets, 2 plus root 2 multiplied by 2 minus root 2. Now, after doing that, you get difference of two squares in the denominator. So you apply difference of two squares to simplify the denominator here. And what does the square difference of two squares is? That when you have a term plus another term, multiply by the same term minus the same term, it is the same as taking the first term square minus the second term square. When you look at our denominator here, we have a term which is 2 plus root 2, the second term, multiplied by the same first term minus the same second term. And so this one too is what? Difference of perfect square. And so we can also take the first term square, which is 2 square, minus the second term square, which is what? Root 2 squared. And then we now have 8. 4 times 2 will give us 8. 4 times minus root 2 will give us minus 4 root 2. All divided by, here we have 2 square, which will give us 2 minus 2. And then we'll simplify further to get 8 minus 4 root 2 all divided by 2. And I caution you that don't be tempted to subtract the 4 from the 8. They are not like terms. The 4 here is together with the side, with the roots, but there's no any roots here. So you can subtract the 2. If you have any question, put it in the comment section. I will be responding. And don't forget, if this actually helps you, don't forget to follow, share, and subscribe for more tutorials on mathematics.